Hey yo, what's up everyone? A new video every day, so as usual this is Code Raw, and today we're gonna solve some lead code problems. Shout out to everyone who followed this channel, who followed me on GitHub, on LinkedIn, and on Instagram. You can find me on those social media platforms. And today, as usual, we're gonna solve some lead code problems. The theme of today is the treasure hunt, so we'll try to solve two problems, which are the maximum average subarray, who's gonna help us to find the stretch of land riches and treasures, and the maximum number of vowels in a substring of given length, which gonna help us to discover the most valuable segment of the treasure map. So currently I'm following the 75 lead code problems. Those are the first 75 problems to practice on, to make sure that you are ready for an interview. So without further ado, let's go to it. Don't forget to subscribe, and this dude helped me a lot through the design pattern. So in the 75 lead code problems, every problem is categorized under a pattern. So with the help of this guy, we can now solve some interesting lead code problems using interesting pattern. I really recommend you to watch his video, and let's go. So the first pattern I'm gonna train on is the sliding window, which has the maximum average subarray and the maximum number of vowels in substring given the length. So let's go to the first problem. Okay, so without further ado, let's jump to it. So I'm gonna just explain the sliding show pattern in really nice and short way. So suppose you have a list like this. I already have a notebook that has the sliding show method. So let's suppose we have 3, 2, 7, 5, 9, 6 and 2. So we have k equal 3. So we're gonna search for the maximum sum of 3 elements and return it. So we're gonna iterate through the list. Let's first we choose the 3 elements and we calculate their sum. So window sum equal 3 plus 2 plus 7, which is 12. And the max sum. Now the max sum is 12. Let's make this smaller. Okay. And this smaller too. This is the first sum. The second sum, window sum, we're not gonna simply go to the next like this or like that. We're not gonna just sum 2 plus 7 plus 5. We're gonna add the first window sum minus 3, which is the previous number, minus 3. We have to focus on that, and plus this 5, plus this 5, and we're gonna obtain 40. And now we have to update the maximum sum, which is 14. So the 12 is already a 3 plus 2 plus 7. So 3 plus 2 plus 7 minus 3 plus 5 is the same as 2 plus 7 plus 5. But using this method, the time complexity will go down, and will continue as that till the end of the list. So every time we update the window sum with the sum of the three element, and we update the maximum sum, and then we return the index of the maximum sum or the maximum sum itself. So without further ado, let's go to the first problem. So the first problem is easy, and it's very similar to the thing I was explaining. So I have this list, which is 1, 12, 12 minus 5 minus 6, 50 and 3, and you have k equal 4. So we're gonna choose 4 element. Those are the first 4 elements. So we're gonna initialize those. Window sum equal 1 plus 12 minus 5 and minus 6, which is gonna as 13 minus 11, which is 2, and max sum equal 2 for now. And then I'm gonna update it. Then you go to the next elements, 2, 12, 15 and 50. Now the window sum will have this 2 minus 1 plus this element, which is 50. So we have in total 51. And the max sum, we're gonna update it. The max sum is 51. For the third iteration, it's the same thing. I'll color it in another. Those are. So in the second iteration, also, I'm gonna need this number 51 minus the previous element, which is 12, and plus 3. So, and the max sum, this is 51 minus 12, 39, 39 plus 3, it's 32. So max sum is 32, and this 32, and now we're not updating it because 32 is lower than 51. So the 51 is the max sum, and this sub list is the maximum sum list. And then we're gonna just return it divided by 4. We're just return, so it's 51, like I said, divided by 4. For now, let's begin the algorithm. So the algorithm is pretty easy, actually. The first element are Windows sum and max sum, and we're gonna initialize it. With the Python, the syntax is pretty easy. We're gonna just initialize the len of the list to iterate it in the next steps. And now Windows sum equal sum of the list until k, which shows the 4 elements. And then max sum, for now max sum, we're gonna initialize it to 0. I think this is, we're gonna find all those in the video I told you about. Max sum, I'm gonna initialize max sum to Windows sum, and then I think we don't need the max sum index. I think we don't need them. So now we're gonna iterate through the list. Change n. So in every time we're gonna calculate the Windows sum and the max sum. The Windows sum operation is pretty easy. So Windows sum equal Windows sum minus minus the previous number, which is this minus k, which is nums of I, or nums of I, plus the element nums I plus k, nums of I plus k. All good. And then we're gonna check for the max sum. So if the max if window.sum is greater than max sum will have the value of window.sum. So if window is greater than the max sum will have the window.sum. I'm gonna repeat this operation until we get to the n minus k index in the list, and then we just have to return the max sum divide by 4. I think this is good. So sum until k, I think this is good. Oh, nums. That's not enough. So Windows sum is not defined. Windows sum. Window. So it's window. Fuck being an issue. Ooh. So look at this array max sum start index, max start index plus k. I think I don't need that. Let's just return max sum. So the max sum is so we need this operator, I think. The max sum is correct. So in this case, max sum divide by k, not by 4. So this test case is good. I don't need this test case. The max sum is It's pretty good actually. Like the Python operator 51 51 51 by 4. Ah, okay. So I got it done. Yeah. It's not enough. It's not enough. So floor division. I think I need the floor division, but the floor division is not really working. So why this test case it's not correct? Just don't try the maximum. So it's correct actually. Is return on 51? It is correct. By let's try to divide it here. And 4 Windows 1 by 4. I'll just here return the maximum. So here Windows sum I want to make it 4. So and then maximum we'll have Windows sum floor, and then if Windows 4. Hey bro, how are you? Thank you, I'm very good. How are you? Welcome stream, by the way. So we just have the problem with the division thing. It's already float. List of end. So we can cast it actually. So cast that. Maximum of some. Okay. Man, it's not like we're working on C. Ne sais pas. I don't know why this is happening, so What do you think of Python for backend? Yeah, I already worked with Python. I worked with Django framework on one of my project. I didn't work with Java, but I'm working currently with at least ASP.NET, and Django is a really good language to begin with, especially if you know Python. You will the syntax will be easy for you, and the thing with Django is that he has a administrator panel, which is built-in function. It's predefined. So if you are making a website with Django, you will already have a user administration panel that is already built in for you. It's a really good framework to begin with. It's friendly, and the syntax Python is not really the hard, and it is a good framework to begin with. And even in the job market, Django is a pretty solid framework. So I really advise you to begin with. But for later, try to work with JavaScript. It's a really good one, like the Node.js framework or something like that. Man, the result is. Can I make it float? Float of this? Or. So between Python and like Java for backend, you think? Yeah, especially if you know Python, because Java, I think the syntax is more harder. It's harder actually, and Python, as I said, it has so much built-in function that can help you, especially if you're a beginner. Man, it's really iconic. So the result is is correct, but when I divide it to 4, it's not. Alright. You're welcome, Blue. Welcome stream, by the way. Should I make it end? End. No. Just don't. Well, don't post any solutions. Average unnecessary detail because sky is fixed. Yeah. For the following code again, the output lead code. However, by charm I get expected output of. Yeah, same problem, man. Just want to know. Float. It is already float, so I cannot do anything. Okay. So we're gonna return it to float. So the first problem is solved. How much runtime? Oh, it's a very good runtime actually. Yeah, it's pretty good. Oh, 2 or 3 minutes. It's not that bad, man. We're doing progress. So let's go. Now we ended up with the first problem of the sliding windows. Now we're going to the second one, and is the maximum number of vowels in a substring of given length. So we have a given length string, and k, which is the length of the substring, and we're gonna count the number of the maximum number of vowels. So basically we're gonna use the same approach, which is gonna define n equal len of s, and then And then let's say Windows sum equal sum of which we're gonna sum now. So now I think we can do a lambda function. If it's one of the vol, then we're gonna add 1. I think we can initialize a list of zeros and the len, and in every vowel we make 1, and then we sum the ones. Yeah, we can do it. So the string, we're gonna make the string a let's say words equal zeros multiplied by the lambda function, lambda a for thank you, man. Welcome stream, by the way. Welcome, man. So a lambda I, we're gonna return for I in S, I'm gonna return, and I forgot the lambda function thing. Lambda function type. So lambda list. It's not enough. It's not enough. Oh, guess what? So the complexity will be it is from the beginning big O of n, so it will not matter. So for a n s, if n. Hey, thank you, man. Welcome stream. So if e and what are the vowels? A O U E E I and Y. So if it's in there, we're gonna assign. We're gonna append of it. We're gonna append dot append 1. Else it's gonna append 0 and 0. let's say we have no in the question. Oh no, thank you. Yeah, we have no y. So this is correct. So let's suppose we have this word, which is the first test case, A, B, C, E, 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 D, E, F. So we're gonna transform it to a list. This will be 1, the B will be 0, the C will be 0, the 3 I's will be 3 ones, the D will be 0, the E will be 1, and the F will be 0. Then we're gonna apply the window sliding pattern like we applied to the previous element. We're gonna check for the K length. So for this one, the sum is 1. For this one, the sum is 1 until we reach this one, which its sum is 3. So we're gonna return 3. So I think all is good. So now, if put that sum, and now we're gonna define max sum. We're gonna initialize it to window sum. This is sum of words from the beginning to K, and then we're gonna do the window sum. And now we'll start. What the fuck? We're gonna start to iterate through the list for G in range len of words. No, not len of words. Len of words until let's just say for E in range n minus q, because we already have the len, and we're not gonna we'll stop here. We're not gonna go to the last or the previous element. We're gonna go to the last k element, which is here. So for G in range n minus q, what you're gonna do, first, like the previous one, it's not the complicated. So the window sum, as we say, plus equal minus words of I, and plus words of I plus k, and then we have to update the variable max sum. So if words window sum is greater than max sum, so the max sum will have the value of window sum. What's more, I think this we don't need no index. Max sum, window sum, and then we're gonna return the max sum. The max sum. So let's run it. So if I invalid print one. If I in so else I think same problem as last one. Why window? Why window? It's window. Okay, so list index must be integer, not Unicode. What? I really don't know why he's doing it. So else window sum equal window sum minus what of I. Oh, minus s, the new list s. S, it's s. No, it's word actually. Yeah, it's word. I just want to print this. I think I can print words, or I have to iterate through it. So let's. Okay, so this is correct. So what is the problem? For G here is G. That's good. Was good. Hey, it's all good. Hey, we solved 2 lead code problems today in 37 minutes. Hey, that's cool, man. It's 1:44, man. So I just want to know what are the others solution. I think so. Max counter string gonna make substrings string dot count. Okay, so he's gonna count it one by one and then just sum it and then search for the max and then return the max. That's cool. So today we solved this 2 problems in 38 minutes. So should go to the next ones. So we solved those 2 ones. Just refresh it. So solved those 2. Let's go to the 3rd. I hope you're all doing good. Hope you're all grinding. It's very cold actually. So we have the max consecutive ones 3. So given a binary array and an integer, return the maximum number of consecutive ones in the array. If you can flip must just tell motion stream. Are you applying to jobs? Actually not, because I'm really I'm a student, so I really don't have that time for jobs, but I am applying for internship and the reply is not now, it's like in February or April, something like that. But I will try to look for part-time jobs. In my country it's not that common to students to work besides their studies, but I will try actually. I don't want anyone to be unmotivated because he watches me doing lead code and not getting a job. I'm not really applying for a job, but I will start very soon. This channel, this thing is just to motivate me and motivate us to grind lead code, daily. So welcome stream, by the way. So I'm from Tunisia, a North African country. Where are you from? So thank you, man. Welcome stream, man. So the difference between the last problem and this problem, in the previous problem we have those ones, zeros, ones, and one. Let's say we count this four, those five. Those are the max 5 element, but they are not consecutive, so this will not work. So I have to change the algorithm. I'm from Brazil. Here even kids apply for job. Wow! But thanks God that's not my case. But yeah, I want to make money also. Yeah, in my country too, kids are applying to job, but not the engineering jobs and like the jobs that are like in the market or plumber or electrical things that are that does not need study, and they are actually how I said doesn't find the word. they treat them shit and they don't pay them well, and it's like child labor if you know. So can you show me your lead code profile? Yeah, of course, I can do it. It's not I'm not the pro, but from the beginning of this series, which is November 16, we did lead code non-stop, just on Sundays. So until now, we solved 41 problems, and yeah. Yeah, same thing here, I think. Yeah. We have a lot in common, Tunisian and Brazilian. Even in my country, they hear the music from Brazil, and hey, thank you, man. Welcome stream. In my country, they hear the Brazilian music, and we have a lot in common, man. I'm new in programming too, and I love it, but I'm more in No. We are getting job, man, and then I have a computing degree. In my country, actually, a lot of people, including me, I was thinking of doing that, of not studying software engineer or computer engineer, and just doing bootcamps and getting a job. It is more. It's like it's more easier to apply a job when you have a computer degree engineer, but man, don't give up. You have your mind, you have all the skills, just grind, and the rest is on God. So don't give up, man. Hey, thank you, man. Welcome stream, by the way. So as I said, and this problem is a little, it's a little too close to the previous problem, but we just have to check if they are consecutive or not, and how we're gonna do this. So let's break it to a line. What is this? Man, I cannot draw a straight line. What? Never mind. So, let's say this straight. It's just a little bit, yeah, and yeah, that's okay. So, bro, that's a great discipline. I expect that even after you get a job and you have no idea how far. Yeah, even when I get a job or internship, I will not stop from doing this, and I hope I will grant the lead code for the rest of my life. Welcome stream, by the way. Welcome, Daniel. So let's break it. We have those consecutive ones. 1, 1, 1, 1, 1, and here 1. Let's say those are 4s. 4 ones. So how we're gonna differentiate those from those? I think in every iteration we have to plus a 1. Or we can check if list of I until I plus k, they are all equal ones, so it is Vmax and consecutive. If it is not, so we're not gonna return it. But he did 3. Most k's. Why k is 2 here? And integer k. Turn the k integer. Return the in the arrays if you can flip at most k zeros. I didn't understand the k. Bloated numbers were flipped from 0 to 1s. Oh. So we're gonna flip the zeros into 1s to make it the most consecutive. This is another thing, man. And here 3, so I'm gonna choose this. We're gonna flip those 2 zeros. And this zeros into 1s. Interesting. And what's the output is 10. So now but now we're not gonna slide the windows with k known, so we're not gonna check for the k element. I'm gonna check for the most. I'm gonna check this. In the previous problems, you have a known k, and the k stands for the number of element that you're gonna sum it. So for example, if k equal 3, we're gonna sum those 3. But now we don't know how much we're gonna sum, and this is the output actually. How much time left is 15, so now how we're gonna do it. We're gonna iterate through the list and slide the windows and check if there is 2 zeros, and if we add those 2 zeros to the ones, it will get us the max of ones, and then we return the max, or not the max, the length of the list actually. We're gonna do it. So let's work on the first test case. 1 1 1 0 0 0 1 1 1 1 and 0, and here we have key equal to. So in this we're gonna choose this, we're gonna make it 1, and this we're gonna make it 1, and we're gonna choose this, and the output is 6, which is the length of this sublist. How we're gonna use the sliding pattern thing? How we're gonna slide? So do we start from 3, like, or we increase every time? Let's suppose we start from 3. Let's call it Q because we have K. Q equal 3. And then when we go this, we're gonna find 2. Gonna find 2. Can we say if the new K is 2, then this is a 0, so we can replace it by 1. And if the next is also the next is 1, so if the next is also lower, so this is a 0, so we can replace it by 1, and then we sum this. But how are we gonna check if this is greater than that? Or just we increment the. So if we make this one, okay, so this will be 5, and this will be 4. So we're gonna replace it by 1 and increment in K, so K will be 5. Okay, that's cool. I think we're gonna have it. Let's just erase those all. Okay, and this and this. So in the previous problem, we know the value of the length of the sliding window, and in this value we don't know it actually. So I think we have to try it. Well, we have to increment it one by one. So we say that the Q is 2. So Q is 2. Then this is 2. Okay. Then we check to the next Q. We will have 2. So we know we have another 1. So we're gonna increment the Q plus 1 to make it 3. Hey, hola! Hey, welcome to stream, man. We're gonna increment it by 1, and then we have the Q equal 3. Okay. And then we're gonna go. Okay, it's 3. Okay, it's 3. And you have to check another time, or we have to go to this. There you go. I think this is bad. So it's 56 minutes. The thing with transforming the zeros by ones and the unknown k is or can we suppose that the k or the is 2? So let's suppose if k it's 2. So we're gonna work with the same k. Okay, so let's say if k is 2. So we have k in this, k equal 2, and the max will be 2. And then we're gonna go to this, max will be 2. Okay. And when we go to this, max will be 1. Will be 1. And I think here we have to increment k. So k equal k plus 1. K plus 1. So the k is 3 now. And starting position is here actually. So it's 3. No. The k value is unchangeable because it is the number of flipping zeros, so we cannot change it. K equal to. Okay, so for example in this 2. Okay, it's 2, and we have to return the max of this. No. Something is not. I think we could apply the numbers like locking them with a for loop and look for the biggest amount of ones and then add the ones of the param. Okay. Well, I think this in the previous problem, which is the max number of walls or the average of subarray, or. But now we don't know in the sliding window, we don't know the length of the sliding window itself. So this is the thing that I'm trying to figure out. If we say that if this subarray dot count 0 equal 2, and the max of it is and the max of it is 5. Yo, this line, yeah, it is. We're now solving the third problem in the slide window thing here. So we are now in this. We solved those two earlier, and now we are solving this one. Welcome stream, by the way. You can have almost k forgiveness. Zeros can be k within. Yeah, we have to find the longest length of the window, but actually I cannot. I think in every iteration or in every I don't know when we have to increment the k, so keep extending and keep track of the number of zeros returning across k and keep track of maximum. Oh, so this count is lower or equal than k. Okay. So in every iteration we have to extend k, and the number of zeros have to be lower or equal than k. Okay. And then we return the max of k's. Okay. The count is more than k, you shrink the windows. If the count is more. Oh. So if we are in this test case, which we have 3 zeros, they are greater than 2, we shrink the window. So we make it like this. No, we make it like this. 2 ones and 2 zeros. Those 2 zeros we can transform them to 1. Okay. That seems good. Okay, let's do it. So n equal len of nums, and then I'm going to define window sum. We have to define no. Window sum will be equal the sum of nums until k. Okay. And smaller than k, and I'm gonna iterate the max sum equal to start at the 0. Okay, let's start it. But we have to start with. Why don't we start with k? I'm gonna need code as well right now. Hey, good luck, man. Keep grinding, man. Welcome stream, by the way. Okay, so okay, because you can have more than k ones. Because you can have more than k ones. Oh, if k is not 2, okay. So here we have to in the numbers of zeros. Okay. Okay, let's do it. And for range n minus, well, it's not n minus q. I think now it's n, because you can go no n minus q. You can do it. Here's thought. Start with 0, keep adding till you have healthy number of zeros. If it gets unhealthy, shrink. If it gets healthy, keep... Yeah, this thought, yeah. So we're gonna keep expanding if we have zeros is lower than k, and if the count of zeros is greater than k, so we have to shrink it. That's good. So window sum equal minus I plus nums I plus k. Because you need two indices for sliding window, one pointing to start of the window and the one is end. No, I think not. In the previous problems we didn't have to initialize two pointers. Well, I have I and I plus k, so I think we're good. Okay, thank you. Now we have to make sure if, so let's just write the normal one. If window sum, it's always window, it's window sum is greater than max sum, then we're gonna assign max sum equal window sum. Have something called zero count. Okay, so I'm gonna initialize it here. For now I'm gonna initialize it to 0, or nums of zeros dot count 0. I think we can call it if window sum. So if window sum is greater than so it is always ones, and the count sum. Okay, so if window sum but we have to divide them to subarrays. The zero count is the number of zeros in a subarray, I think. So in every iteration we're gonna count it. So 0 count If it is zeros in a subarray, then why do you calculate it already as zero count of the entire array? No. If it's zeros in subarray, then why do you calculate already? To know if the numbers of zero, well, in here I'm just initializing the if the first element it is zero or not. So if it's zero, it's gonna tell me then there is 1 0 here. But in my opinion, you should add zero count whenever you counter zero in your subarray. Yeah. So that. So here. So here I'm just gonna initialize zero count equal the nums from I to I plus k dot count. So we're gonna count the number of zeros in this sliding window and check. And now I have to check if it is lower than, I can be quite a... No, man, you're welcome, you're very welcome. I'm just sharing ideas, you know, but you might be on the wrong path. Yeah, I can be, so let's just test it. Let's just try my idea, test it, and then we can try yours. Thank you, by the way. So if zero, I just didn't understand your idea. For that I'm trying mine, and then I'm trying another approach. Thank you. So if zero count is lower or equal to k, then we're gonna expand k plus colon. It is a this condition. It is here or not? No. Oh, okay. Elif. Then I'm gonna But now we're not changing the max sum. We are returning the k. I think max sum, I'm gonna make it max sum multiplied by it's k multiplied by 1, and then return the max sum. Because I don't see why we're using the max sum already. I'm just gonna make it as a comment. Maximum equal k multiplied by 1. No. Equal k. How about the whistle fresh? Man, I just want to try my idea. Just a second. So if k, so, and then we're gonna return k. Hey, do you want to hop on a Google Meet or Discord? I think we can communicate better there, if you want. So let's just try this. Okay. You're good. Yeah, okay. If you don't want, it's cool, man. So you're I'm saying, man. Welcome, by the way. I don't really often meet girl in those. I've been doing lead code all day today. Good to for you. Thank you. Welcome to stream. But really, I'm not. I cannot communicate so good with you in the chat. You know. If you want, you can write your solution and just send it in the chat. I'm gonna copy paste it and then we're gonna discuss about it. No problem. We're gonna collab some other day. Sure. Yeah. Welcome. So, zero count. Okay, I'm gonna just initialize it to 0. Okay, so so output is 11 and he's given me that's a good start. Yeah, at least we have no errors, but I think he is returning the 1 2 3 4 5 6 7 8 9 10 11. So he's returning the length of the string. So like he's summing all those if those are ones. He's supposing those are all ones and he's summing it. Okay, now inside the for loop, remember if nums equal 0, increase 0 count. Oh, yeah, okay. Okay, so if nums of y equal 0, so we're gonna increase k. So I think those two condition will be both in those two, I think. Like it is a one condition. It is a one condition. So I can put it in one condition. Okay, think about this. So this condition for increasing window. This condition for change. So the condition of expanding the window is we have a number of zeros lower than the k. So for example, if we have only 1 0, we can expand the window, and for shrinking we have more. No, that's the condition. I write it here. For shrinking, so if the number of zeros is unhealthy, you shrink, right? Yeah, I think, yeah. So if we have 3 zeros, if we have no, it's not like that. I'm not finding it. So if I have 1 and 2 zeros and then 1 and I have k equal 0 equal 1, no, we are expanding it. So let's say we have 1 0 0 and 1 and we have k equal 1, so k it is here, we have to expand it. No, we cannot expand k greater than its value, but if we have, if the max value of k is 2, no, okay, it's number of zeros, man, this this is actually fucked up. I think I'm disturbing you. How are we gonna do it? I think, yeah, we have to start fresh. Let's erase all that. 1 1 1 0 0 0 1 1 1 and 0. So, and we have k equal to, so let's start k with 1. Okay, so I have k with 1. If number of zeros is lower than 2, which is, we're gonna expand it. So let's say expand 0 count should be lower than k. And for shrink, so if we have, then we're gonna expand it, then we're gonna expand it, then we can expand it more, and here why we even have to shrink it? What are we trying to create? Welcome stream, by the way. We are not creating anything, we're just solving some lead code problems, the daily challenge of solving lead code problems. So now we are solving the sliding window, which is the pattern to solve the max consecutive ones. So we're solving some lead code problems. Welcome stream. Why do we even have to shrink it? Consider this. Okay. You have to shrink it because you only allow 2 zeros. Oh. No. Why shrink it? Why we just keep it like this? Oh, if the other test case is 0 here. And no, if k equal 2, then we don't have to neither expand neither to shrink it. We just keep it like that. But if we are now in this case, which we have 5 element but 3, so if zeros count is greater than k, then we have to shrink it. So the condition of expanding that k is lower than zeros count is lower than k, and if the zero count is greater, then we have to shrink it. So for now those two lines are are good. Those are good. And then we're gonna compare the new k to the previous one. You only perform shrinking and expanding, right? But you have a good idea. Why? Those are two conditions. If we find k equal max number of zeros, not your length, your window, these windows. Okay, so window sum here is greater than max sum. Then I'm gonna make max sum is window sum. That's the basic, like all the previous problems. Okay. But we're not gonna return window sum because if we are in this case, which is the right case, so we have only four ones, and we have to return 6, which is k. No, it's not k. Is max, is window sum plus k. Is window sum plus k. Is window sum plus k. Which variable k? Window sum. Window sum plus k. I think this is good. Because in this example we have 4 ones. The last sub array we have 4 ones and k is 2, and the output is 6. So we're gonna max sum plus k. Should I give the answer for this is not right. Max sum plus k isn't the right answer. It's not enough. It's not enough. Why, man? Yeah, okay, give it to me. It's already 30 minutes. Cannot make longer. Your window include k zeros. You should return max sum. No, it doesn't include. The window is summing the number of ones. I'm just gonna try this, and if it's correct, then we're gonna correct it. It is fault. Okay, so what is this thing? Oh, okay, sorry. Window is the entire, yeah, it's the entire window, but consider this as a window. Where is the mouse? Let's erase all this, and let's erase all that. So consider this as a window. The sum of it is 4, but the output is 6, so we have to add it k. You feel me? So okay, 12. Good start. Okay, let's try some. Max sum will be 1. Oh, you are calculating sum, not length. Yeah, I'm calculating sum. But here the max sum equal 1. and I don't know why. I'm not updating the window sum. So the window sum. Okay, so if you are calculating sum, then you should add nums a to your window sum. Yeah. So window sum minus nums of I plus nums of I nums of I plus k. List out of index. Okay, so but why we don't add the I plus k like the previous one? Output 0 it's not calculating. Window sum. No. We have to add something. Plus, not minus. But this is not the formula, man. Because k in your previous problem probably is the length. Yeah, and this problem is not length. Yeah, it is not. If he return k equal 5, then we're good. No, that is not. Yeah, understand you now. 12. So it is 12, and here it is 19. I want him to print just to check the array. Print nums. I want to find string and print 0 counts. So now the first iteration we have 1 and 1. Okay, so we have 0 count, and then we have 1 1 and 0, and we have 1 0 count, and we expanded the k. Oh, we expanded it, but we went to this index. We didn't expand it from this. So should not go. It's not necessary. Are you tired? It's not. That's more important. Figure out what's your window like this. No, I'm not tired. It's not necessary. You'll have. Okay, serious. I'm just gonna try it. I really can't understand you right now because I'm not really processing well. So I'm just gonna print the result and find out what the algorithm is doing. So now, in this case, he finds zeros, so he expanded chi by 1, and he went to this index and he calculated this, and he shouldn't do that. And I don't really know why he is doing this. Try with a smaller example, please. You'll get it. let's say 1 0 1 1 0. Okay, so the first one, so the first thing we did is like this. 0 is lower than, okay, so you're gonna expand it, but he have to expand it in place. In this algorithm he's expanded it and going to this index. I think I don't know why the index I is changing. I don't know. Oh, I think we have to change places. I think we have to do this first. Just gonna check it. Oh, the videos is not enough. Not enough. So 110, and then he went to the other one. Why he's going to the next index? I don't get it, man. Couples. Yeah. No, I'm doing good. Plus equal. It's a plus. Do you think it's? Oh, okay. So equal plus. What's equal plus? No, I don't really get it. I don't really get it. We are adding 1 to the k. Why? It's a prefix, not a suffix. No. It's not adding. The k is not changing. Okay, I'm just gonna write it simple. So this k equal k, and this a k minus 1. I think we're good. It's the same thing. Check if line 16. Windows arms equal. Oh, okay. Hey, yes. Same problems. Girl, you're driving me crazy, man. No, it's really nice to meet you, nice to work with you, but I'm not really getting it. I don't know why the index is changing. I don't know. No, welcome, man. But the stream is gonna end up like 2 hours. Do you want to join Google Meet? Yeah, if you can. I'm not showing your face. Don't worry. If you want, send it on my LinkedIn, or do you want to send it here? As you want. Man, the life is 2 hours. I will check it with chat and just that's not enough. So he initialized two pointers, one left and one right. He began to iterate the list with right, and whoever he find is zero, he increment the left by 1 and the zero count plus 1, and then he returned the max length. I usually do this in Python if someone uses faster language. Yeah, I think bro, do you code in C++? Or I'm doing it in Python right now, but I usually code in Java. But I think this problem will be easier to write in Python. Language doesn't matter as much. Hey, the K girl, the K username. I will like to really have a meet with you if you want. Contact me on LinkedIn. It will be such a nice meet if you're comfortable with it. So the alternative problem, the alternative solution, is that we can initialize two pointers, which are left and right. So I'm gonna make this in comment. Okay, so we're gonna initialize one left pointer and max length and zero count. This is it, and then we're gonna iterate through the list with the right pointer. And if I really didn't see it. I don't know why I cannot see links in the Google chat. Yeah, I am still in unis. If you want, contact me on LinkedIn or Instagram. Just send me there the link. Thank you. OP, object oriented. Ignore. So he iterates through the list with the num right. If it is 0, then he's gonna increment the 0 count. If the 0 count is greater than k, so the nums left will be 0, then he's gonna decrement it and increment the left one, and then he's just gonna return the max between max length. He's not gonna use the window sum. He's gonna use the length of the list, actually. It's not enough. Increase window if zero count is good. Shrink. Yeah. That's the right thing. So let's just. Hey, did you send me the link, because I didn't receive it. So an indented. Oh, that's problem here. Okay, so let's just erase that. That is right. So I think this is it. Is it, and the runtime is not that bad actually. So there you have solved 3 problems in nearly. We did those 2 in in 50 minutes. We did solve 2 problems in 50 minutes, and the other problems we spent like 50 minutes on only 1 hour, but it is really hard, so it's cool. It is the optimal solution. Yeah, I think it is. But in Java, the runtime will be slower. So if it's equal 0, then you're gonna decrement, and if it's equal 0 and k, it's lower than 0, he's gonna increment it, and then he iterate with the while loop, so you're gonna increment the I and G. There return G minus 1 minus I, which is the right pointer and the left pointer. Okay, that's cool. So with that, we can end our stream. Thank you everyone. The views today is are really good. So with that, we can end our stream. Thank you all for following. Thank you all for subscribing. Thank you all for the support. I'm really grateful for the support. I really happy to interact with you and communicate with you. Thank you all, and hope I can see you tomorrow. I'll see you tomorrow. Okay, so this is the end of stream. See you tomorrow.